Hi there, today we are going to make traffic light projects with Arduino in Tinkercard. I promise I'm not going to make this video boring. I'm going to make it as short and concise as possible. So first access tinkercard.com and then create a new design. Select circuit here because our project that we'll be working on is a circuit. And of course, first thing that a circuit needs is a power source. The power has to be coming from somewhere. So we could of course use examples of power sources battery, but in this case we are going to use the Arduino Uno board. And as you can see here, there's power coming from somewhere. So you are rest assured that this board is full of current. So next thing, traffic lights, first thing that comes in your head is light. So we need something that glows. So examples of things that glows is a light bulb, LED. But in this case, you're going to use an LED. An LED basically is a short form of light emitting diode. So to understand that, you also need to understand what a diode is in the first place. So a diode basically enables current to flow in one direction. And connecting that understanding with LED, light emitting diode, that means this turns on if current is flowing through the right direction, right? So you're going to need 3 bulbs because traffic light is red, yellow, green. Here we go. And as I said, red, yellow, green. So we need one to be green, one to also be yellow, and one is also red. Nice. So you have our 3 bulbs here. Next thing is we can just go ahead and connect everything up here. But the small problem is we don't know the amount of current flowing through here. And we don't know how much this LED will be able to take. So if the current is too much here, and then we connect this small LED here, this LED may blow up. And there's no way we can also know the current going through here. So we need something, something magical that will just limit the flow of current from the board to the LED and make sure we get the perfect current going through the LED so it doesn't blow up. And that magic component is called resistor. So resistor, as I said, resists the flow of current. Nice. So now we have our resistors, we have our LEDs, and we have our Arduino board. Again, we can also go ahead and connect all of this, but imagine how messy it will look here. I like to work neat. So to make things neat here, we need something that will at least give us a larger surface area to make, connect all our components, and then everything will look pretty neat and simple. So that magical thing is also called a breadboard. Here we go. Nice. So what is a breadboard and how does current go through it? So again, think of breadboard as something that just gives you a larger surface area to try out your stuff. Instead of you connecting directly, you can just use a breadboard and then you have lots of holes here that you can plug in and then use the same current that will be going through here. So how does it work? Well, there are 2 sections of the breadboard. You have the top and down, and we have the middle, right? Top and down and middle, 2 sections. So on the down and top, current flows in a horizontal manner, but on the middle, current flows in a vertical manner. So if you connect a current a wire through here, and then you get, as you can see, it's been even highlighted. So current is flowing through in a horizontal manner. But if you connect a positive charge here, also current will be going through a horizontal manner. But if you connect it up here also, current will rather be going in a vertical manner. So first, let's set up our stuff and then get our traffic lights project going on. So first, we need to find a way to connect the Arduino board to the breadboard. So we are connecting from the ground to the negative side, and then anything here also to the positive side. So to get the ground, it just counts from here 1, 2, 3, and then the fourth one is the ground, as you can see here, denoted by G and D. Nice. So now every single current going through here is the negative current. So next thing also is to find a place on the breadboard to place our LEDs, and it has to be in that order: red, yellow, green, so that we can get the perfect traffic light. Okay, so now we have resistors. You have to find a place to put them on here, and you also have to connect the positive charge also. So again, on the LED, there are two sides that you can connect your wire to. There's a negative side, and then there's a positive side. The positive is called anode, and the negative is called cathode, just so you know. So we are going to connect a positive charge also. First focus will be on the red light. We're going to find ways to make sure the red light works. Okay, nice. So now positive is going through all of here, negative is going through all of here also. So here's where our resistor comes in. So as you can see, the resistor is taking the positive charge from here and then connecting it up here. But as different from the below, where current is going through, on the horizontal side, on here current is going through the vertical side. So that means our red bulb is getting exactly what it's supposed to get, where is the positive charge. And then next thing is also have to connect the negative to the negative side also. So here we go. So now we've successfully completed our circuit on the red bulb. So on the yellow bulb, you can also still connect, since they all need the negative charge. You can also connect all of them here, and then you are done. So now, big question: how do we connect the positive charge also? Because we don't want to be using one pin port from here. We will be using differently, so that if current is not going through here, at least all of the remaining two will be going through, and to make our programming of this board also pretty easy. So we're going to find a way to connect another positive charge from a different source to our negative end, to our positive end. So now yellow is getting a positive charge from somewhere nice, and then of course we are not going to forget our resistor, which is what I brought here, and then we are going to do same also for the next port. Nice. And where is our resistor? Yes. Nice, here we go. Okay, perfect. Hooray! So we've been able to connect our LEDs directly, and it's working perfectly. So now let's start it up and see what we've done so far. Alright, great. So now current is only going through the red side, so you have to find a way for the red to light up and then go off in a couple of seconds, and then the yellow also lights up, and go off in a couple of seconds. Then green will also light up and go off in a couple of seconds, and then the cycle also repeats again, so that we get perfect red, yellow, green, red, yellow, green traffic light. So to do that, we need to program this. So we are done with our setup here, but we need to program how the lights are going to be moving around. So we go on here, we are going to use Scratch, and then let's remove all of this stuff on here. So here's forever. Forever is basically a loop. So it's like it's running forever. You know, it never stops, so that we get red, yellow, green, red, yellow, green. If we limit it to, like, let's say run for like 5 times, just be red, yellow, green 5 times, and then it stops. And that's not how traffic lights work. Traffic lights are meant to, you know, work every single time, because if they go off, bad things happen. So first thing first, we are going to find a way to turn on the red light, because traffic light is red, yellow, green. So set pin. So we first have to zoom in here, and then we'll figure out what specific pin is the red LED connected to. So we just follow on here, 13 connected here. Okay, nice. So red is connected to pin 13. So set pin 13 to high, and high or low is basically Scratch's way or Arduino's way of you know, showing if the bulb should be on or off. So if it's high, that means the LED should be on, and then if it's low, that means the LED should be off. So now we found a way to let the Arduino board know that pin 13 should be on, right? So successfully turn on the red light. So whilst pin 13 is on, we have to find a way for pin 12 and pin 11, that's the yellow and then the green LED, to be off. So you are going to pick up the same code block over here. So pin 12 should be low, and then pin 11 should also be low. Okay. So high means on, low means off. So set pin 13 to high means set pin 13 to on, and then set pin 12 to low means set pin 12 to off, same as pin 11. So now 13 is on, 12 is off, and 11 is off, which means red bulb is on, yellow is off, green is off. If you don't do this, all the lights are going to light up at once, which is what we don't want. You want it to be in a harmonic order. So red on, green is off, and yellow is also off. So this is a forever loop, right? So it's just going to repeat itself, repeat itself, repeat itself. So first, we also need it to wait a little. We need some intervals between in there. And this interval is going to enable us to, you know, divide between when red should be on, when yellow should be on, and when green should be on. Without this delay or this wait number of seconds, it's just going to be on throughout. So wait 1 second, and then we bring in this same code block here. And then 13. So in this case, so 13 should be on, 12, that's yellow, should be off, green should be off, and then wait 1 second and make 13 off rather, and then make yellow bulb on because it's time, and then 1 second has passed. And then the final one is pin 11, which is green LED, should rather also be low. Okay, So in the first code block, red is going to be on, the rest of the LEDs are going to be off. The next one, yellow is going to be on, the rest of the LEDs are going to be off. And then of course you also need a waiting time also to come in here. So wait 1 second, and then guess what, the final one, we need green to also be on. So we bring green on here also. Sorry, we got the wrong log. Okay, here we go. Perfect. So 13 is here. 13 is going to be off, which is the red light, should be off. And then 12 is also going to be off, which is low. So remember, off is low, on is high. And then the final one, 11, is going to be on. Okay, perfect. So again, going through it, first code block says red light should turn on, and then red light should wait 1 second, and then red lights will go off, and then yellow will turn on, and then green will go off, and then wait 1 second, red will go off, still will be on off. We can even, you know, make it shorter, but just to explain it perfectly, yellow should also be off, and then green should be now on. But now green is now on. So when do we actually get back to red for it to turn on? Because if green is on and we don't bring a wait time here for the loop to repeat itself again, it's just going to finish up on green and we didn't know what to do. So to finish this up, we need to also add the wait time over here also. Oh, you know what? Yes, exactly that. So we are done. So on starting the simulation, red is going to turn on first, and then wait 1 second, yellow is going to turn on, whilst all the other bulbs are off, and then finally green is going to turn on, wait 1 second, and then it repeats itself again. So our traffic light project is finally ready. Let's get it started and see what we've been working so hard on. Fingers crossed, guys. Woo! We did it, and it's even in a perfect form now. So as you can see here, our traffic light project is finally ready. Red, yellow, green. Drop any comments or any questions that you have about this, and I'll be happy to assist you. Cheers, guys.